Hello students, welcome to Narayan College online classes. In the last video, we have discussed about the chemical properties of 17 group elements. So in that one, we have discussed about reactivity and oxidizing power. Clear now? And here the third concept is oxidation state. Clear? So oxidation state, you know that halogen atoms, all halogen atoms, all halogens, they need one electron to get the stable, that is noble electronic configuration. So that's why all elements of 17th group has a tendency to accept one electron, so they will show the -1 oxidation state. Clear? But if you see the fluorine shows only -1 oxidation state. Why? Because means you know that fluorine doesn't have any empty d orbital and it is the most electronegative element in the periodic table. Clear no? And next one, if you take remaining halogens like chlorine, bromine and iodine, they can show the along with -1 oxidation state, +1, +3, +5, +7 also. In some cases, they can show the +4 and +6 oxidation states. So what those we will discuss one by one. So first one here, you know, all elements of 17th group, all elements of 17th group, show -1 oxidation state. But you know that fluorine shows, you know that here fluorine shows only, you know, one oxidation state, that is -1 oxidation state. Fluorine shows only -1 oxidation state. Clear? And but you know, remaining halogens like chlorine, bromine and iodine, they show, clear? They show along with -1, +1, +3, +5 and +7 oxidation states. So how they will show the +1? This is mates, and I will write here ground state electronic configuration, mainly for chlorine, bromine and iodine. Common electronic configuration, you know, Ns2, what is it here? Np5. 1, 2, 3, 4 and 5. This is the electrons. Clear? So now it is in the ground state. You see, if I write here ground state and one electron is there here, outermost, seeing unpaired electron, only one is there. So that's why they can lose this one electron. If they lose one electron, they will show the which oxidation state? +1 oxidation state. Losing electron, one electron, if any element loses one electron, +1, plus charge you will get. Clear? And if it gain one electron to get the noble gas electronic configuration, gaining one electron means which oxidation state it will show? -1. That is all will show the -1 oxidation states. Clear? So this accounts for -1 and +1 oxidation state, this electronic configuration. Clear? And first excited state, if I write, first excited, yes means excited state, means except fluorine doesn't have the, you know, d orbital. So that's why chlorine, bromine and iodine, they will have which orbitals? D orbitals here. So first excited state means one of the electron from the p orbital, it jumps to the d orbital. So that's why 1, 2, 3, 4. This electron jumps here. Then how many unpaired electrons are there here? 3. If these 3 electrons, if the elements lose, then they will show the which oxidation state? +3 oxidation state. In the same way, second excited state. Which one here? Second excited state. Means another one electron will move into the d orbital. So here one electron, it will move into the d orbital. Then how many electrons it will have? You see, already one electron is there in the d orbital. Now we will get one electron here. Probability of 5, so it accounts for the +5 oxidation state. If they lose all these unpaired electrons are participated in the bond formation, they will show the which oxidation state? +5 oxidation state. So in the same way, third excited state, then this s electron also and entered into the d orbital. Clear here? So 1, 2, 1, 2, 3. So how many electrons are there? Here 7 electrons. So this accounts for plus 7 oxidation state. And I already mentioned along with this and chlorine, bromine, iodine can also show chlorine, bromine and iodine. Clear? No? Mainly these two, chlorine and bromine. Clear? And it can also show mainly chlorine and bromine and iodine can also show which oxidation state? Plus 4 and plus 6 oxidation state in their oxides and oxy acids. Their oxides and what it is not here? Oxo acids. Their oxo acids. Simple example, if I take here chlorine. ClO2. O2 means what is the oxidation statement? Plus 4. If I write ClO3, what is the oxidation statement? Plus 6 oxidation state. So this is about what it is here. Oxidation states of what it is here. 17th group elements. So next one is here reactivity towards hydrogen. Same like 15th group, 16th group, how we have discussed. In the same way, we will discuss here also reactivity towards which one here? Hydrogen. All the elements of 17th group, they combine or react with the hydrogen and forms the hydrogen halide type of HX. Clear? So here, what is this one? All the halogens. Clear? So here, suppose halogen, if I mention X2, it is a X2, and they combine with what it is? Hydrogen, and it forms 2 moles of what it is? HX type hydrogen halides. HX type halides. This we will call as which one here? Hydrogen halides. What is here? HX type hydrogen halides. Can also be called as halogen acids also. Clear? Suppose HCl is there, and you know this is chloric acid. We can say here hydrochloric acid. Clear? So this is halogen acids. Clear? Or we can simply say halogen acid. Can also be called as what is here? Halogen acids. Halogen acid. Because we will call HCl is there, hydrochloric acid. We will say that acid is belongs to which one here? Halogen. So that's why halogen acids can also be called. So this is X means what it is here? X is equal to chlorine, bromine and iodine. HX, and if I write here instead of HF and what it is HCl, HBr and HF. Hydrochloric acid, hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, all are acids. We will discuss. Clear? One way. Now this is they form the HX type of hydrogen halides. Now properties are very, very important for these halides. Sorry, hydrogen halides. Properties. Very, very important for this is for the PU as well as competitive, mainly for competitive properties. Clear? So properties of hydrogen halides. Clear? The first one here is physical state. Put the heading. First one is physical state. Clear here? So first one is physical state. Clear? So what is this one is? HF is a liquid. HF is a what it is here? Liquid. And remaining all HCl, HBr and HI. These all are what it is here? Gases. These all are what it is here? Gases. So why HF is liquid and remaining all are gases? Clear? Why? Because this is due to the intermolecular hydrogen bonds in its molecule, HF molecules. In what it is HF molecule. And why this means due to why HF is a liquid and remaining all are gases means it is due to what it is here? Due to intermolecular hydrogen bonding. Hydrogen bonding in HF molecules. In what it is here? HF molecules. Clear? Simple. If I write here HF and here, clear? So here there is a HF molecule. Like that if I write. You see over here, what is there here? There is a hydrogen bonding highly electronegative atom and hydrogen which is attached to also highly electronegative atom. So this is what we will call here hydrogen bonding. So that's why because you know that fluorine is small in size and high electronegativity, so that's why it can easily form the hydrogen bonding. But remaining halos means halogens, chlorine, bromine and iodine, they cannot form the hydrogen bonds among their molecules. Clear? So that's why you know HF due to this more hydrogen bonding. Clear? So hydrogen bonding is here very strong, so that's why molecule come close to each other, so it is in the form of liquid. If weak, then molecules move away from each other, then they are in form of which one? Gas. That is the case. This is the first one. Clear? So next one here is boiling point. Next one, what it is here? Boiling point. Clear? If I take here boiling point, so what is the boiling point of these molecules? And here I already mentioned boiling and melting points, how they depends. Boiling and melting point depends upon which one? Size of the molecule. As the size increases, van der Waals forces also increases among the molecules, so automatically melting and boiling points also increases. Clear? So that's why melting and boiling points mainly depends upon which one? Size. As the size increases, boiling and melting points also increases. Clear? So that's why if I take here HF, HB, HCl, HBr, HI. Clear? You know here carbon is already hydrogen. So that's why if you are moving from chlorine to bromine and fluorine to iodine, the size increases. Clear? So HF molecule size is small and HI molecule size is bigger. So that's why what will happen? If you take here and in this case HF molecules are very small. So and these are along this small length van der Waals forces existed. But if I take HI molecule, this is one HI molecule. If I take another HI molecule, this is the another HI molecule. Then what happened? You see, and along this length, hydrogen bonds existed. So are not hydrogen bond, van der Waals forces. These are the van der Waals forces. Along this, what is here length? It is van der Waals forces increases compared to here. You see small length. In this length only van der Waals forces existed, but here length is long. Along this length van der Waals forces increases, so then automatically boiling points also increases. So that's why, so which one should have the highest boiling point here, and HI should have the highest boiling point. This is the R. But you know that in this case the boiling point R is slightly changes. And what is that? It is HCl and HBr is less than what is HI, and HF should come here. But where the HF means, and here this is HF. Clear? Why it means same? What is the reason here? Because of intermolecular hydrogen bonds existed among the what it is HF molecules. So that's why, and that increases the what it is boiling point of the HF. Clear? No? So why HF is having high boiling point here? Because HF has high boiling point due to what it is here? Intermolecular hydrogen bond. Intermolecular what is here? Hydrogen bonds. Intermolecular existed in which molecule? HF molecules. Clear? So that is the what is order here. This is the very important. Clear? In the same way, melting point, as I already mentioned here, melting point, boiling point and melting points depends upon the what size. But small change here, you will get HCl, HBr, and here HF, and what is lost here HI. Clear? So when compared to the boiling liquid and it is solid. So here HF comes before the HI. Means what does it mean? Van der Waals forces dominates the what it is here. hydrogen bonding. So that's why. And HI melting points, if you take, HI will have high melting point compared to the what is HF. Clear no? So this is melting and boiling points. And the next one is here. This is the second and the third and fourth one. Ionic character. Ionic character. Clear no? So what about the ionic character? Clear? I already mentioned here Poisson's rule previous for covalent compound and ionic compound. Clear no? For covalent compound you know cation should be what it is. Cation means what? Having positive charge. Cation should be large. Clear no? Anion should be what it is here? Small. Anion should be small. Clear? And charge should be what it is here. Charge should be what it is here? High. Charge should be what it is here? High. Clear? So cation will be reverse I have done. For cation should be small. Cation should be small, and anion should be what it is large. Then charge should be what it is high. This is for covalent. And what is the for ionic ionic reverse? Cation should be what it is large. Anion should be small, and charge should be low. This is so if cation is small, it will have the high polarizing power. Okay, so it will show the covalent character. So this is reverse. So that's why compare here now ionic character. Clear? So if you compare the ionic character and here HF, HCl and HBr and what is my last one? HI. Now which one is more ionic? And more ionic means in case what it is if you dissociated HF plus F minus and HI dissociated H plus and I minus. So all cases proton is common, cation is common, H plus, H plus, H plus, H plus. Anion you see. If you see the anion, it is a F minus, Cl minus, Br minus and I minus. Clear? So anion size increases from the fluorine to iodine. Anion, to show the more ionic character, anion should be small. So that's why and HF is a more ionic. Or otherwise, you know that if electronegativity difference is large, then the molecule will show the ionic character. So that's why HF is a means ionic character means HF molecule. HF will show the more ionic character compared to the remaining all. Clear? So that is ionic character. And ionic character next one is here dipole moment. Dipole moment. Clear? Dipole moment. What is the dipole moment? Dipole moment depends upon the ionic character. As the ionic character increases, dipole moment also increases. Polarity increases, automatically dipole moment also increases. Clear? This is more polar molecule. So that's why more ionic. So what is the order here? HF is greater than HCl is greater than HBr is greater than HI. Just remember, dipole moment is directly proportional to electronegativity of the element and also directly proportional to polarity and also directly proportional to what is called polarity or sometimes ionic character also. So this is that's why where the electronegativity atom is more and here fluorine is highly electronegative atom, so that's why it will show the high dipole moment. And this is and 50 what it is what dipole moment. And the next one is here bond length. Put the heading bond length. So these all are there in the NCERT textbook only. Clear? So next one is bond length. Some are there and some are not there. But important for here bond length. Clear? So if I compare here HF, HCl, HBr and HI. Clear? Bond length means you already know that here. HF hydrogen is a small molecule and fluorine also small. So that's why here bond will be very strong. Because you know that both the size of the molecules are same, then overlapping of those orbitals are very strong, so the bond is very strong. Bond when it will be strong, if the bond length will be very short. Clear no? So that's why, and HF both are small, so that's why, and here bond length will be very shorter. And if you take here, clear no? This is the bond length, center to center. Clear no? So where the bond length is greater or longer. Here bond length is longer and here bond length is shorter. So that's why what is the bond length order here? Bond length order is in this way. Clear? HI will have the molecule have high, means R you can say bond length is long. Clear? So now what about the bond strength? What about the bond strength? Clear? So bond length and bond strength both are inversely proportional. Clear? So bond strength is inversely proportional to bond length. If bond length is long, then that bond can easily break. Clear? Overlapping of these orbitals are not much, so that's why weak bond you will get. So that's why what is the bond strength here? Reverse R. Clear? So what it is here? HF. Clear? So bond strength means this is HF, HCl, HBr, and what it is here? HI. This bond easily breaks. Why? Because bond length is here long, so that's why easily the bond. You just take the simple example. Take one stick, long stick, clear? And you can easily break that stick. If the length of the stick is more, then easily we can break. And take the same stick with small length. Can we break easily that is? No. We have to supply lot of energy to break that. Clear? So that's why if bond length is more, clear? So that bond can be easily breakable. Clear? So that's why, and here bond length is more, so that's why bond strength will be very less. Yeah? This is about the bond strength. And the next one is here. Next one, property, eighth property, and acidic character. What is one here? Acidic character. Clear? So acidic character means that which one gives the H plus ions easily. That is the more acid. All these compounds, hydrates of halogens, or you can say means hydrate of halogens have the hydrogen atoms here. So that's why they can give the H plus ions easily. They can give the H plus ions. But which gives the H plus ions very easily, and that is the strong acid. So which gives the H plus ions easily, and which bond breaks easily, and that gives the H plus ions very easily. Got my point, Maya? And acid means it should give the H plus ions. So which gives the H plus ions very fast, and that is the strong acid. Among these, which gives the H plus ions very fast, and which is having the weak bond, that gives the H plus ions very easily. So which among this, which has the weak bond? HI has the weak bond, so that's why HI is the strong acid among these four. Clear? So that's why what is the character here? Acidic character HI is greater than HBr is greater than HCl is greater than HI. Among this, HI is a strong acid and HF is a weak acid. And the next character here is reducing power. What it is here? Reducing power. Yeah. So what is this reducing power? We have already discussed previous also. Reducing power means the capacity of the molecule to reduce the other substances. To reduce the other substance means it has to it has to provide the hydrogen atoms, then only other molecules get reduced. What is the reduction? Reduction means gaining of hydrogens. So all these have hydrogens. So which can provide the hydrogens easily? That is the strongest acid. Which can provide hydrogens very easily? Which bond is very weak? That bond breaks easily, and that compound gives the hydrogens very easily to other atoms. So that's why other compounds will get reduced. So here reducing power depends upon the way what and capability to or the tendency to give the hydrogens. So which one has highest tendency to give the hydrogens? Hi has highest tendency to give the hydrogens because it has weak bond between the hydrogen and iodine. And this is about the what it is here properties of hydrates of halogens. So next one is and reactivity towards oxygen. Halogens reactivity towards hydrogen we have completed. And next one is reactivity towards oxygen. Okay? And 17 group elements or you can say halogens can form a number of oxides. Clear? So here I have written, so which oxides mainly they form. So here oxidation state +1, -1, +1, +4, +5, +6 and +7. Clear? So fluorine forms only monoxides, oxygen difluoride or dioxygen difluoride. Clear? They cannot form other oxides here. And chlorine, bromine also cannot form the monoxides. And chlorine forms more number of the oxides compared to the other halogens. Clear? So what is that one is chlorine monoxide, chlorine dioxide, trioxide and Cl2O7. Clear? Heptoxide also. Clear? And next one is bromine. Bromine forms mainly three oxides: monoxide, dioxide and trioxide. And iodine forms tetroxide and pentoxide. I2O5. Clear? So this is mainly, so what it is, 17th group elements that you can say halogens forms mainly this type of oxides. Clear? If you see the first one here, fluorine. Clear? Fluorine forms two types of oxides. Fluorine forms how many types of oxides, Maria? Fluorine forms two types of oxides. Two types of what is Maria? Oxides. One is OF2 and another one is that what we will call this is oxygen difluoride. Oxygen difluoride. And second one is here O2F2. Dioxygen difluoride. So but in this one, among these two, OF2 is stable at room temperature. It is very, very unstable. So only OF2 is stable at where Maria? Room temperature. And O2F2 is highly unstable. O2F2 is highly unstable. Clear? And these are called actually oxygen fluorides rather than oxides of fluorine. Clear? So why? Because first of all, which one is here OF2 means you know that OF2. Oxygen is highly electronegative than the fluorine is highly electronegative than the oxygen. Fluorine gets which charge? Negative charge. Oxygen gets which charge? Positive charge. Negative charge is there means what we have to call? Fluorides. Clear? Oxygen it is there. Why we cannot call here fluorine oxide? Why we cannot call fluorine oxide? Oxide means what it is, man? It should form -2 or minus oxidation states here. Yeah, total -2 and here what is +2. Just if I say here. Clear? So what happened here? If it is means it is like this. If you say oxides, fluorine oxides, if you say oxygen should get what it is negative charge, but oxygen and fluorine, which one is more electronegative? Fluorine is most electronegative. Clear? So that's why, and it will take the electron from the oxygen, so that's why it will be converted into F minus. F minus means what we have to call fluoride. So that's why these compounds are called. These are called oxides. These are called oxygen fluorides. What it is, Maria? Oxygen fluorides rather than. Clear? So rather than what it is, Maria? And fluorine oxides rather than fluorine oxides. This is important. Clear? So another one is, and both O2OF2 and O2F2 are powerful oxidizing and also fluorinating agents. Yeah. So both what is OF2 and O2F2 are oxidizing and powerful fluorinating agents. So what is this oxidizing agent means? We already, what is our fluorinating agent? Oxidizing agent means what? It it oxidizes the other substances by providing which one? Oxygens. And fluorinating reagent means what it is? It fluorinates the other compounds by providing the fluorines. That will be called as a fluorinating. So that's why here very important one use is there, and that is O2F2 is used to remove the plutonium. Plutonium is there, clear? So in the spent nuclear fuels are there, in that one plutonium should be removed. How they will remove means by using this O2F2. So O2F2 is a fluorinating agent. Fa means what is one? Is fluorinating agent and is used to, or suppose simply you write here O2F2 is a fluorinating agent. It and fluorinate and plutonium to what is here? Plutonium F6. It converts the plutonium to hexafluorofluorine. Clear? So this is about what is here? Fluorine. So it will form two types of oxides. So one is OF2 and OTF2, and these are OF2 is stable and OTF2 is highly unstable. These are called oxygen fluorides rather than the fluorine oxides, and both are strong fluorinating agents. So that's why OTF2 is used to remove the plutonium, to remove the plutonium in the form of plutonium hexafluoride from the spent nuclear fuel. So this is about what it is here. So next one is, so we have completed oxides for the fluorine. Now we will discuss about the oxides of fluorine, bromine and iodine. Just now only we have discussed and we have drawn one table. So there oxides of fluorine, bromine, iodine I have given. So they will show the oxidation states. Chlorine, bromine and iodine, they shows the +1 to +7 in their oxides. Okay? So but if you go for stability of these oxides, so this is important. Stability of oxides. So which oxides means mainly I will discuss about the chlorine, bromine and iodine. Okay? The stability of oxides. Okay? So because you already know fluorine oxides are very unstable. So O2F2 is highly unstable and OF2 is stable at room temperature. So stability of oxides if I take, and iodine oxides are more stable and then chlorine oxides. Okay. And the least stable oxides are bromine oxides. So which oxides here? Least stable one, bromine oxides. So why iodine oxides are most stable? Okay. Why? Because the reason for this is the polarity, high polarity between the oxygen and iodine. Iodine, so it is less electronegative, and oxygen is a second most electronegative element. Okay, so that's why, and if I just simple I will write oxygen and iodine bond. If you take iodine and oxygen is highly electronegative, iodine is less electronegative, so that's why this bond is highly polar. If it is highly polar, it is most stable, and that is due to high polarity of iodine and what it is oxygen bond. Iodine and oxygen bond. Yeah, this is why iodine oxides are most stable. And second one is chlorine oxides. Next, actually, which one should come here? Bromine, but which is coming here? Chlorine oxides. Clear? Why these are very stable means, and you know that here, and capability, chlorine has the capability to form the multiple bond with the oxygen. That is clear what it is here. Chlorine has capability to form multiple bonds with oxygen. Clear? You know that chlorine it will, and bromine. So if you take the chlorine and oxygen will use the p orbital, and this chlorine will use the 3p orbital, and it is 2p orbital. So overlapping will be more, and they can show the what it is here. They have the capability to form the multiple bonds with the oxygen. And bromine is in between them, so lack of both the characters, it will have the which bromine oxides are what it is here least stable. This is the order of oxides. Okay? And if I take here chlorine oxides, what are the chlorine oxides we have written in the table? So Cl2O and ClO2 and ClO3, and the last one what it is Cl2O7. Yeah, and these all are highly reactive oxidizing agents. These are what it is are highly reactive, what is oxidizing agents. All are oxidizing agents. And here ClO2, chlorine dioxide, is act as bleaching agent. Is act as which one here? Bleaching agent. Is act as which one here? Bleaching agent for paper pulp. What is here? Paper pulp and textile. Paper pulp, textile, and here, and the next one is the textile and in water treatment, and in water treatment. Clear? So this is about which one here? Chlorine oxides. Clear? And next we will discuss bromine oxides. Clear? Stability of oxides here you already know. So next one is bromine oxides. Bromine forms which how many types of oxides here? Mainly 3 types. What are those oxides? We have already written. So what is that one? First one is Br2O and BrO2 and BrO3. So these are main oxides of what it is here least stable. These are the least stable. Just now only we have discussed. Br2O, bromine monoxide, dioxide and trioxides are least stable halogen oxides. Least stable halogen oxides. These are least stable. Yeah? So they exist at very low temperatures because least stable. So if you maintain high temperature, they will break down the molecule. So that's why they exist at very low temperatures. And here, because these are very unstable, so that's why they can act as a very powerful oxidizing agents. They are very powerful oxidizing agents. Very powerful what it is oxidizing agents. And this is about what it is here and oxides of bromine. Yeah. So are least stable among these. Which one is the least stable oxide here? Bromine oxides, and they exist at low temperature because they are least stable. So low temperature, and they are very unstable. So that's why they can easily break and they can give the oxygens very easily to others. So that's why they are very powerful oxidizing agents. And if you go for oxides of iodine, oxides of which one here? Iodine. So that iodine forms mainly 2 types of oxides. One is I2O4 and another one is I2O5. They are insoluble solids. These are insoluble what is here? Solids. Insoluble solids. They are very stable. Okay? So that's why they decompose at very high temperatures. They decompose at high temperature. Decompose at high temperature. And I2O5 is a good oxidizing agent. And this I2O5 is used in the estimation of carbon monoxide. Estimation or detection of in the carbon dioxide. Carbon dioxide, if it is present in the atmosphere, to detect that carbon monoxide how much it is present, and whether the carbon monoxide is present in your sample or not, to detect. Clear? Our estimation also we will use what it is here I2O5. Clear? No? Very important point here. I2O5 is used in estimation of carbon monoxide. Clear? No? So how to test, I2O5 whenever it is reacting with the carbon monoxide and it gives the iodine and 5 moles, here 5 means you have to take 5 and 5 moles of carbon dioxide. Clear? So this is about the what it is here, oxides of 17th group elements. So next one is here reactivity towards metals. Clear? No? So you know that here 17th group elements are, you can simply say, halogens. When they react with metals and it forms the metal halides. It forms the what it is here, metal halide. I have taken here metal is monovalent. Which metal I have taken here? Monovalent metal I have taken. If I take the monovalent metal, I will get the metal halides. Clear? And X means what it is here? X is equal to fluorine, chlorine, bromine and iodine. Clear? So now if you take these metal halides, what is the character, ionic character? Clear? If I write here MF, clear no? And MCl, MBr and MI. So what is the ionic character? You know that ionic character? Covalent character, cation should be small, anion should be large. But you know for ionic character, reverse it is. Cation should be large and anion should be small. So here, what is the cation? If MF bond breaks and fluorine gets negative and metal gets the positive, halogens will get the which charge? Negative charge. Metal will get the positive charge. Metal in all cases same only. Don't bother about that. And you see the anions. Which anion is present here? F minus, Cl minus, Br minus, and what is this? I minus. Clear? So you know that to show the ionic character, the anion should be small. So among these, which anion is small? Fluoride is very small. So that's why it will MF is the more ionic compared to the this is clear. So what is the ionic character for this is which character here? Ionic character. Ionic character. Order of ionic character. So this is order of ionic character. But in some cases, so if it is showing more than one oxidation state, metal is showing more than one oxidation state. So in that case, halides with higher oxidation, metal with higher oxidation state, clear, will show the mainly covalent character compared to the covalent character increases as the charge increases. Clear? So a simple example I will say here. I will write here one compound SnCl4, SnCl4, and another one is SnCl2. So which one is more covalent? SnCl4 or SnCl2? Cation is same. Here also cation is same. Anion is chlorine. Here also anion is chlorine. So that's why then what you have to see? You have to see the charge. So here, what is the charge here? +4 oxidation state. Here what is +2. So this is more covalent compared to the SnCl. More covalent compared to the what is here? SnCl. In the same way, SbCl5 you see, SbCl5 and SbCl3. Which one is more covalent? SbCl5 is more covalent. So that's why whenever and same element will show the different oxidation state, and you know that the highest oxidation state compound is more covalent than the less oxidation state compound. So that is the statement here. So what is the statement? If the metal exhibits more than one oxidation state, the halide in higher oxidation state will be more covalent than the one in lower oxidation state. It is more covalent compared to it is which character now? Covalent character. Covalent character. Clear? So this is about both of which one here? Covalent character. So if metal shows the more than one oxidation state, clear? More than one oxidation state, then the metal in high oxidation state will be the more covalent compared to the one in low oxidation state. And this is about what it is here. So reactivity towards metals. and last one is reactivity towards halogens. Reactivity towards halogens. Clear? No? So here, important concept. This is separately we will study about this. Clear? No? So here halogens combines amongst themselves form a number of compounds called as interhalogen compounds. What is here? Interhalogen compounds. Clear? What are the interhalogen compounds here? Halogens combine amongst themselves to form number of compounds called as what is my interhalogen compounds of type clear? Of type what is my XX dash 3 and XX dash 5 and XX dash 7. These are clear? So here X means here large size halogen. What is my halogen? This is separately interhalogen compounds are there separately we will study. There I will discuss detail. And here small size. What is my small size halogen. Clear? Means simple. Suppose if I write here example ClF. Clear? Interhalogen. Two halogens are there. Interhalogen. Or you can say ClF3 and Cl. Or you can write here Br F5 and you can say IF7. These are which one? This type. Interhalogen compounds. Clear? So this is about the reactivity towards halogens and reactivity towards metals. So next one is anomalous behavior of fluorine. Clear? Previous we have discussed anomalous properties or anomalous behavior of 15th group elements nitrogen and 16th group element oxygen. Now what is fluorine? Why fluorine shows the different behavior compared to other elements means due to the four reasons. Same anomalous means you have to write this four. What is one? First one is small size, high ionization energy, high electronegativity and absence of reactor. And some points differences between fluorine and other elements. Clear? The first one is reactivity. You already know that this is reactivity. I have already discussed. So reactivity, if you say fluorine is highly reactive. Fluorine is highly reactive compared to the what it is other elements. That is one anomalous behavior. Why? Because it has a high standard reduction potential. Clear? That is the first behavior. Clear? Next, the second one, oxidation state. Clear? Oxidation state, what it is? Fluorine only shows -1 oxidation state. Remaining, you see, fluorine shows only -1. Remaining chlorine, bromine, and iodine, they will show the -1, +1, +3, +5, and +7 oxidation states. This is also one of the different behavior. Fluorine only shows the -1. Remaining all will show the +1, +3, +5, and also hydrogen bonding. This is important. Hydrogen bonding. Hydrogen bonding. You know that fluorine being a small in size and highly electronegative, and it can form the hydrogen bonds in their compounds. So that's why you know that HF is a which one? Liquid. Have I mentioned that not? HF is liquid. Due to which one? Hydrogen bonding. HB means what? Hydrogen bonding. And remaining HCl, HBr and HI. All are which one? Gases only. So that's why fluorine containing compounds showing different behavior than the chlorine, bromine and iodine containing compounds are not. That is due to what is hydrogen bonding. Clear? And also you know that due to hydrogen bonding, fluorine forms, acid salts. Clear? Due to hydrogen bonding and the fluorine, and here what is forms acid salts. What it is here? Acid salts. Clear? So what is the type of acid salts means? KHF2. So here why? You see, this is how we can write K plus. Shall I write this is K plus and here F minus and hydrogen bonding the what it is HF. This is salt. Clear, boys? So that is another one. And also next one is nature of bonding, nature of compound. What it is here? Nature of compounds. Clear? You know that fluorides are, most of the fluorides are ionic compounds. What is here? Most of fluorides are which one? Ionic. Clear? Simple example, if I say AlF3 is a ionic. AlF3 is a which one? Ionic. If you take AlCl3 or AlBr3 or I3, all are which one? Covalent. All are which one? Covalent. Clear? These are what it is? Some different behavior. And also I can write here another one, reactivity of halogen acids. Next another behavior, what it is? Reactivity of what it is here? Hydrogen or halogen acids. Halogen acids. Clear? You know that HF is a highly reactive compared to the HCl, HBr and what is here? HI. So that's why, and HF can easily attack the glass also. Clear? So why? Because means it can easily attack the glass. Its ability to displace the oxygen atoms. Clear? From the sodium silicates. Glass is mainly made up of what do you know? Sodium silicates. So that's why HF is highly reactive. Compared to what is here? HCl, HBr and HI. So that's why it attacks. Clear? Glass. It attacks what is here? Glass. What is glass here? Mainly made up of Na2Si, sodium silicate, and it will attack, and it has the ability to replace the what is oxygen, because fluorine is more reactive than oxygen, so the oxygen atoms will be replaced. So then what we will get? Na2Si F6 plus what it is here? H2. Hydrogen and oxygen will be removed in the form of then how many fluorine atoms are here? 6. So let's multiply this one 6 and oxygens will be 3. So this is it. And also oxidizing power, you know that fluorine is most powerful oxidizing element compared to the others. Okay? So these are some differences. We have the different behavior of fluorine with the other halogens. So that's why we will call fluorine is a super halogen. Because of these all properties, fluorine is called as what it is here? Called as super halogen. Fluorine is called as what it is here? Super halogen. So this is about what it is here? Anomalous. Means anomalous behavior means you have to write here 4 points. Write the anomalous properties or anomalous behavior of the fluorine is because of 4 properties. Small size, and second one is high ionization energy, high electronegativity and absence of d reactor. And in which properties fluorine differs with the other halogen elements means, and these I have written. First one, what it is? Reactivity. Fluorine is highly reactive compared to the other halogen atoms. Oxidation state, and fluorine always shows the -1 oxidation state, but rest of the halogens will show the -1 to +7, -1, +1, +3, +5 and +7 oxidation states. And also hydrogen bonding. Fluorine containing compounds can form the hydrogen bonding, and chlorine, bromine, iodine containing compounds cannot form the hydrogen bonding. That is also one point. And next one is nature of compound. Most of the fluorides are ionic because fluorine is highly electronegative, so automatically metal fluorides are always ionic only, and that is AlF3 is ionic and remaining covalent. And reactivity of halogen acids reactions what? HF or HCl, HBr. Among HF, HCl and HBr and HI, you know HF is highly reactive. It can attack what it is not glass. So that's why this can also be used in etching of what it is not here glass. So glass formula mainly it is made up of Na2 sodium silicate, and you will get the fluorine will remove the oxide. So that's why because of these all properties, fluorine is called as a superhalogen.